Problem 16.61. In this problem, a solid plate with a thickness of 15 centimeter and a thermal conductivity of 80 watts per meter Kelvin is being cooled at the upper surface by air. The air temperature is 10 Celsius, while the temperature of the upper and the lower surfaces are 50 and 60 Celsius respectively. Determine the convection heat transfer coefficient of the air at the upper surface and discuss whether the value is reasonable or not for forced convection of air. Looking at this problem, we have two modes of heat transfer. So if this is the plate, this is maintained at TS2 and this is TS1. Between these two surfaces, there is going to be conduction. And then at the upper surface, there is going to be convection. For conservation of energy, the amount of energy that is done in conduction inside of the plate has to be equal to the amount of convection that is lost from the plate to the environment. Okay, so now let's write what the amount of conduction is going to be. It's Ka, the difference between the temperatures TS2 minus TS1 divided by the distance in between, which is the value of L. The amount that we have for convection is going to be equal to HA TS1 minus the ambient temperature. And as we said, for conservation of energy, these two quantities are going to be the same. So we're going to write them all together. Ka TS2 minus TS1 divided by the length is equal to HA TS1 minus T infinity. Notice that the area is not provided in this problem, but luckily, due to the balance of energy, the areas cancel out. So now what we're looking for is the value of H, so we're going to solve this equation for it. H becomes simply K over L TS2 minus TS1 divided by TS1 minus T infinity. So now let's replace the values. The value of K is equal to 80 watts meter Kelvin. The distance between the two plates is 15 centimeters, so it's 0.15 meters. TS2 is 60 minus 50, and this is Celsius. And TS1 is 50, and the temperature of the ambient is 10. Once again, this is Celsius. Celsius and Celsius cancels. Meters and meters becomes meter square. So this becomes simply 133 watts m square K. The second part of the question is asking us to describe or talk about whether this value of H is a reasonable value. For that, we go to table 16.5 in your textbook, which is given over here, and notice that we're looking for forced convection and for air, and air is a gas, so we're going to go over here for forced convection for gases, and notice that the range is between 25 and 250 watts meter square Kelvin. Our value falls within that range, which means that the value that we obtain is reasonable for this particular problem.